Alright, we're going to look at making some changes to GCC's C++ compiler. So, how do we actually do this? So right here is the installation link, and there's quite a lot that it says you have to do to compile GCC, and that's pretty much true. What I found to be a very useful page is actually the wiki here, which has some simpler instructions on what to do. You can certainly follow all these instructions to get a more in-depth idea of what to do. I found that this is really useful when I get stuck not quite understanding, these essays of text. So we need to actually download GCC, and to do that we're going to use git. Alright, and I think it shows, if we click here, it tells us exactly where we can download it. We'll just copy this and open up our terminal, and I've just made a folder for this, and we're just gonna run that command, git clone. So I'm going to use VS Code for this. We're going to open our GNU CPP hack tutorial. This is the repository we're downloading. Alright, cool. Our repo finished downloading. So let's take a look at what we got. We have a GCC folder, and these are all the files in it. Right, so the first thing we want to do is just go back to our main directory here, and we'll go into the GCC repo, and we're going to call this contrib / download prerequisites script. There's a few supporting libraries that are required for GCC to compile. Now, again, this helpful document here tells us in a pretty terse way how we can do this. So we're going to go back into our console. In fact, I'm going to move this over to a different screen just so I can reference it. Alright, and now that we've downloaded the prerequisites, we're going to create a new directory. In our main directory, we're going to call it objdir. So this is where all the binaries will get compiled to. And we're going to run the configure script. And actually, we want to make sure we run this from a folder outside of the GCC repo. Apparently there are issues if you run it from within that folder, so we're not going to do that. We want to run the configure script, and we're going to give some options to this. We're going to set a prefix for where we're going to end up installing this to. We don't want to install to our, our system directories, because we want to be able to use our regular GCC for in case we mess something up, or just generally for, we want to have these things separated. This is going to be in projects / GNU-CPP hack and GCC, right? Yep. And then we're going to also set the enable languages parameter, and all we really want is C++. GCC has support for a whole bunch of different languages, and the more we add, the longer it will take to compile, and it takes a really long time to build GCC, unfortunately. For me, it takes about almost an hour, so we'll go ahead and run the configure script. Oh, I forgot. For me, I want to be giving it the disable multilib parameter. That just makes it so that we're not building for 32-bit. And yeah, so this is going to take quite a while. For me, it takes a little less than an hour. but yeah, we'll see. Alrighty then, GCC is finished compiling, and the next thing we want to do is just run make install. So that's going to install into that directory we created. So if I do ls ... and you'll see we created that, hold on. Wait, where did I configure it to? I configured it to, the completely wrong thing. Okay. Well then, it does appear I have made a mistake that has cost me over an hour. So I accidentally, when I ran the configure script, set the prefix to not this folder, but this folder. And this is the repository folder. And that's not right. Yeah, so I made a critical error, unfortunately. And we're gonna have to start this process over. Well, I am. You are gonna do much better because you're gonna have the actual correct commands. Yeah. We're going to put this in the GCC install directory. Alright, see you in presumably an hour. Alright, so let's try that again. Make install. Okay. We're getting results this time. So, now that we've done that, now if we look in GCC install, we will see, yep, we got a bin folder in there, and that is in fact where we have good old G++. So here's our test code, right? And we want to use, it's the wrong folder, GCC install, and yeah, we're just gonna go ahead and see if it works. Okay, make failed to launch, what? Right, and we're going to want to actually use the correct folder, or file, so that'll be in bin/G++. Yeah, let's try that again. Aha, it works. Okay, and there we go. So, clearly, the compiler that we compiled gives us the ability to compile. Great. But yeah, let's say we have a lambda, right? Something like this. And we say like autof equals this lambda. Maybe it's got like a parameter like int x, and all it's supposed to do is return x times 2. Very trivial, contrived example. But yeah, we'd like this to be, you know, a lot of times something like this kind of seems like should be a one-liner. But the syntax isn't exactly terse in C++. You know, you have to put everything in braces, and there's going to be an extra semicolon, and you even still have to type return even though there's just one expression. Yeah, so the kind of thing we would really like to be able to do is something more like this. Yeah, where we have, you know, the same syntax for, you know, specifying the parameters, but we kind of want to do something like just x times 2, and there's some kind of syntactic separator here. For now, I'm going to just decide to use double colon. You know, it'd be kind of cool if we could do like this, but I found it's a little hard to do that, so we'll see what we can do, but for now we'll just use double colon. So yeah, obviously if I try to compile this right now, yeah, we're gonna get some issues. We haven't added that's not in this regular C++ compiler, so let's see what we can do about that. Alright, so we're gonna go ahead and open our GCC repo folder. So the first place that we're going to be looking at is cpparser function body. And you might be asking yourself, well, how do I know that? Well, I think the way I went about it before was I just sort of searched for lambda. Obviously that was the thing I was interested in. And I got the idea that it looks like most of these parsing functions just start with the prefix cpparser. So I figured, okay, well, let's just try look for cpparser lambda. And that does appear to exist. So we go through this a bit, and looks like we have a cpparser lambda expression. So let's look what's in this. Eventually, I ended up finding a path to the function body. Right, so cpparser lambda body, and yeah, you can see this. This just eventually calls into cpparser function body, right? And this is good, by the way, because this means we can use our syntax potentially on declared functions rather than just lambdas. Anyways, what we've got here is it's just calling into another function, actually. And basically it's saying that a parser function, or the function body, is just a compound statement. And when it's saying compound statement, it's just talking about something that's in a like a block like this. You consume an open brace and then kind of loops through a bunch of statements, which is what parser statement secopt does. So when I was trying this out for the first time, I kind of found that, there's a lot of stuff in this compiler, and, it's going to be probably a really hard thing for me to just figure out all of it at one time. So what I kind of decided was, well, there's a lot of code that just does a lot of what I already want to do, right? So basically we just want to transform this almost, because this here is supposed to be equivalent to this, right? So what we actually want to do is not changing a whole lot. So we can use the, intuitively we could use the code from whatever parses a return statement, but the only difference being that we don't actually check for a return token. Instead we look for this double colon instead of a left brace. And then whatever's after that, before the semicolon, is what the expression would be in a return statement, right? And it happens that all of those things exist for us already, which kind of makes sense. All that stuff has to be in the parser somewhere. So let's take a look and find out where all that stuff is. Well, we don't really need to parse a compound statement. We really just need to parse one statement. But it'll make our lives a bit easier if we just use this, because there seem to be some supporting functions for this kind of thing. And it changes a lot of state, like there's these begin and finish functions, which change a bunch of state having to do with, I think, sort of semantics of what this stuff actually does. Yeah, so if I go look through here, and again we have that cpparser statement, sequence optional. That's a mouthful. But yeah, that sounds like where we're going to be kind of looping through all the statements in braces. And then we have this function called cpparser statement, kind of sticks out like a sore thumb. So let's take a look at that. And then you find that this is just basically a really big switch statement. What's interesting for us is where it's looking for these different jumping statements, different control flow statements, which, it kind of lumps all together into this cpparser jump statement. And that's where we're going to actually be taking the code for our return statement that doesn't require a return keyword. So we do have to go down a little bit, but eventually find where it's looking for a return, and it also looks for co-return, because this is C++ 20, and We have coroutines now, but that's not really what we're interested in, so we'll see if we can factor that out. You may have seen it before. There's this function called cpparser next token is. We can just use that function to check if we're either seeing a double colon or if we're seeing left brace. So yeah, let's try that. So we're going to use this function. It's called cpparser next token, which kind of makes sense because we're dealing with the lexer and not really the parsing phase. But yeah, the parser has this field in it called lexer, and we're going to ask it for whether it sees this CPP scope as part of this CPP T-type enum, which is, I assume, just stands for C++ token type. So basically, our logic will be inside of this if statement. A good thing to do at this point is probably just to see if the compiler still works. Like, did we happen to break anything by just changing a few lines of code? So yeah, I mean, let's try that. And at this point, you might be wondering, well, how do we compile this? Do we just do the same thing? And yeah, pretty much. So as long as we're in our obj-dir, we can just say make. And oh, another command that we do want to run is make install. We have to do that every time we build. Since we're making reference to our GCC install directory rather than just using the pure compiler executables that it creates. And the only reason I'm doing that is because I don't know how to use those exactly. They expect certain files to be in certain places. Yeah, all we're really checking to see is if we broke anything. Everything compiled, so hopefully everything's alright. And yeah, it compiles just fine, and I'm guessing it runs just fine too. Yep. So what we're going to do first is just go into this compound statement function and look what it does. And in fact, I'll just go ahead and copy paste the whole function, and we'll just remove whatever it is we don't need. It actually, checked for the left brace. So it's kind of a sanity check, I guess. Well, we're actually not requiring that. Remember, we just want the CPP scope to be there, and that is, of course, the double colon, if I forgot to mention that. So we actually don't want to do this, but we do need to consume our CPP scope token. This function here doesn't actually consume it in the list of tokens, it just checks, but it doesn't do anything to the state of the lexer. So yeah, we can get rid of this, and the function we use for that is just cplexer cplexer consume token. And that actually returns the token that we're consuming, but we don't really need to do that here. Next, it's checking for, what kind of function this is, and actually, we don't need any of this if statement here, because this will actually never fire. So this function body variable here is actually a parameter to this compound statement, and yeah, you can see we're always giving it true normally, which makes sense because, yeah, of course this happens at a function body, so that's normally how we're going to call it. So yeah, we don't need this at all. Yeah, we do this begin compound statement. Again, that's one of those functions that just appears to do something not necessarily having to do with parsing, but sets some state about what we're about to do. So I'm going to keep that. Well, this is actually for label declarations, and we don't really want that. We're not going to allow labels on the anything after, the colon. That's, we can get rid of that. And then this is where it's going to, parse the sequence of statements that would normally be inside of the curly braces. Here we want to do something fairly similar, but we just want to look for one statement, and it's also going to be required. You would have to have a statement there. Yeah, and this function, it's just doing some checks to see if thinks that there's going to be another statement in this sequence. So it's doing stuff like looking for close braces or the end of a file, that kind of thing. But that's not really something we have to worry about because we know we just have to parse a single expression. All we actually want to do is, just find the code that's in that return statement and just call that. So it doesn't seem like we actually have to do any of this other than just looking at the cpparser statement. And there isn't anything in here that's, really changing state other than just doing parsing. So I don't think we have to worry about any of this. But here's where it actually parses the statement. So let's just kind of look inside this. Before that, I also found it really helps if I just, whenever I'm going into a new function and starting to kind of transform that into something else, that I just, maybe comment this out or something and just put a code block here, just so I know that I've entered sort of a new context. This is helpful especially because, we're probably going to be referencing to some variables which are actually just parameters. And so yeah, that'll be a little bit useful for us just to remember where we're at. And let's go into cpparser statement. Again, we have this a bunch of cases for different keywords that we find, right? But before that, it does things like declare a bunch of variables and decides if it looks like there's just some kind of predicate here that fails, and it just returns a null tree. But long story short, I kind of found that we only really need some of these variables, not all of them. Actually, we don't need the std_attrs variable. But yeah, let's just for now put this in here. Oops. And yeah, we'll just remove this std_attrs variable. And yeah, I don't think we need this either. But yeah, we're gonna take a look at what comes after this. We're not really sure if we want to do this stuff. We know we don't want to do this because we're not using Objective-C. But yeah, let's just kind of go down a bit and look at what this code is doing. So the first interesting thing, I think, is we're taking a look at the first token we see, right? Well, what is this used for? So we're assuming there's this keyword in the token, and based on that, we're going to go ahead and figure out what kind of statement this is. It could be a good idea to go ahead and copy this stuff because, well, it turns out it's some stuff that we need. Okay, yeah, and we'll just paste this in here. And in fact, something I just noticed is, we don't have a variable called BCS flags. This is from the compound statement parse code. But we can find that this is actually the BCS flags variable, and we're just passing it all of this. So we may as well just take this and put it in here because that's all it is. And we could even do one better and just make a variable for it. And we'll just call it BCS flags. And we can also just factor this out too. Yeah, I went ahead and opened another, or split this file over here. Yeah, so we want to go back to that statement parser. Yeah, so what happens when we're trying to parse a statement is, yeah, we're just looking for these keywords. And in our case, we already know what we want to do. We just want to go ahead and act like we're parsing a return. So we can just look for that in here. Yeah, and there it is. And now this makes a call whether it's a break, continue, return, co-return, or go to. But we'll just try and use that for our purposes. So I'm just gonna copy this, and yeah, we'll put this here. But in the case of cpparser jump, we're gonna go into this and see what it does. Before we do that though, before we get ahead of ourselves, something I'd like to do is just kind of go here and at the end, because there's going to be some code that we probably want to add to the end. Yeah, see, we don't care about this because we don't care about these attributes. The attributes are actually stuff like this, where you say this is like if it's a return, you might say something never returns. It's something like that. It's not really a feature I ever use, but yeah, it's not something we actually want for this code. At least not for now. We're just trying to make a basic change. And set the line number. That's actually something we want to do so that, you know, everything gets entered into the part of the compiler that I assume wants to show line numbers for errors. So we'll do that. And yeah, all these variables are here, and part of why we kind of, you know, already put these variables here is because we can find what depends on what just by finding what code we needed to use and then looking at what variables they're using. And so that's why we use these that came at the beginning of the function. And yeah, we're gonna go ahead and see what's in here. And I'll just go ahead and say that, yeah, this is where we parse the return. That's where we parse a jump statement. Now, in our case, we already know exactly what kind of statement this is. We know it's a return statement. The first thing that happens here is it just saves the token, which is not something, it's not exactly what we want. But this does tell us that we're kind of on the right track. Just, you know, looking for one of these tokens. But again, that's not something we actually need to do in our case. So yeah, what we actually want to do is look for this part of this code that is going to do the stuff for the return statement. Yeah, so let's look for that. It looks like this is actually for checking if you do something like this in C++, which means you're you're returning some kind of data structure whose type is able to be deduced by the compiler. But yeah, let's just go ahead and take this, and we'll see if this is going to be useful for us. Right, so we'll just put it in here. At this point, by the way, we can start to see what variables we're missing. So as you can see, our function here doesn't contain this variable at all. But if we go back to this function that we're copying from, here's that variable. It just is declared at the top of this case. Yeah, so we'll just declare it the same way it's done there. And we also have this expr variable, and we'll just go ahead and declare it the same way. Oh, and also we can go ahead and remove this. And that's commented out here so we remember what we're emulating. So let's take a look at what we actually copied. And again, we want this code so that we can return and initialize our list. This is actually checking that the token is not a semicolon. Yeah, so that's actually what we want. But yeah, you can see this is where just after the return keyword, we're actually parsing the expression inside of that. And that's all we want, really. We don't check for a return because all our syntax is double colon and then the expression and then semicolon, and that's it. So at some point we need to add this finish return statement, and I kind of deduced this, you know, the first time I was doing this just by seems like every time we go into, or most times when we go into a new sort of semantic part of the syntax, like go-tos or code blocks or something like that, that isn't just purely syntactical but has a actual meaning, it means we have to call like some kind of finish function. So it looks like we actually do need this. So we'll just go ahead and add this to our code. But before that, what's this else if here? Because this could run either way, even if this isn't co-return. And it looks like it just depends on if we're inside of a discarded statement. I honestly don't exactly know what that means. I'm not gonna lie. All of this stuff I have no idea about. Full disclosure, like I know a little bit about compilers, but a lot of this stuff is really over my head. So anyways, let's take this code here and just finish the return statement. But after this, we're back out of this block, so we can look back into what we were originally doing, which is just, doing what we had to do to create this compound statement. So we haven't called a finish compound statement, have we? Well, that's actually something we do need to do. And I already ended up putting this here because, it seemed like that's something we have to do. So yeah, we do that. Now here, it's wanting us to, this is just something we copied, consume a right brace, but that's not actually something that we want to do because that's not part of our syntax. And after that, we also had this return statement that we copied, and this function actually we is just void. We don't return anything, so that's superfluous. We don't have to do that. And another thing to notice here is we don't have to actually do this check here because we know we're inside a function body. A lot of this is definitely trial and error, so you have to expect going into this that you might not exactly know what you're doing. I certainly didn't when I started doing this, and I kind of still don't, because I mean, this is about as much as I've done is just try to add this very simple syntax. Now, going through here, I just noticed some things. First of all, we don't need this variable at all, because we're not using the braces code, and we don't need that. Another thing is we don't actually need this statement token declaration. We don't use that anywhere, so we'll remove that. Okay, and yeah, we also don't need this statement hotness attribute thing because we're not doing anything with those like return statement attribute stuff, so we'll get rid of that. Yeah, right here also, this can just be an else. For a return statement, it's okay to for there to not be an expression there. In our case, that's required, so we just remove that. Basically, it's just an error if you don't have an expression here. And for what we're doing here, that might actually be it. And there's really only one way to find out. Yeah, let's see what we get. Alright, well, everything compiled successfully, so let's do a test and see if things worked out. And let's see what happens. Oh, well, we've got a compiler error, but it, at least it didn't segfault. Oh, okay. When I put int here, I thought I was specifying the return value of the function, but this is a lambda, so we'll just put auto. It makes more sense. Let's try build. And we've still got we've got a different error. Okay, well, I was kind of racking my brain about what was going on. I was checking my reference code and everything seemed correct. But what I just noticed is I never ran make install. So we have to do that. Otherwise, our executable doesn't get updated. And we'll try to compile again. Oh, it compiled this time. Okay. Cool. It's not going to do anything else because, well, this lambda is just sitting here not doing anything, but let's just try print a string based off of this lambda, and we'll call this lambda, and give it a, let's say 44, and that should print out 88, of course. Well, let's see. We compile it. Aha! Look at that. Okay, well that's pretty cool. We've actually made a change to the C++ compiler itself. Before you'd have to do, instead of this, you have to type the return statement explicitly and everything and use 2 semicolons. Yeah. And as you can see, they both do the same thing, and I can even use them both at the same time, you know, just to test that, you know, there aren't any conflicts or anything. Say G44, and they should both do the same thing. Compile that, and yeah, so we just get 2 of the same thing happening. Oh, great. Now, I think I'll leave this for now, but something else I did was add this kind of syntax where, you know, we can do the same thing, but for function declarations. And actually, you know, when I first did this, I thought it might just work because, you know, function declarations just end up using the same function for the body, parsing the body. It's cpparser function body. Let's see what happens. And we get an error, actually. And we get an interesting one. It says expected initializer before :token. And that's because it's actually looking for different stuff that could come after the parameters in a function declaration. So, you know, you can have, at least in structs and classes, you could have like equals delete and equals 0 and stuff like that. But I'm gonna leave it here for now because I think this gets the gist out there. We actually didn't have to write that much code to get this working. I mean, if we look at this, I mean, this is all the code we had to write. And yeah, I mean, you know, to add functionality to the C++ compiler, I don't know, I just think that's pretty cool. That we've made a change, you know, we've added syntax that we wanted, but the possibilities are kind of endless almost for this kind of thing. I mean, you know, just think of anything in C++ that's ever bothered you. You thought, well, it'd be really nice if I could do this, or maybe even add like a completely new feature or something to that's even higher level than parsing. Like you want to add something to the type system or something, you know, like that, or new literals to the language. But anyways, that's about it, and hope somebody gets something out of this. And yeah, bye.